Alright guys, in this lesson we are going to study the properties of elements, and there is a homework associated with this lesson. It's the Properties of Elements worksheet, and I will have it copied for you in class. But what I want you guys to do is copy down this "do now," because we will do that when I see you. And that should go on a separate page under classwork in your binder. And in addition to that, you can write down that you'll need to have this done on that day, and also when we get to the pair up and the summary, then copy those down as well on that same page in classwork. And then the rest of it, you can just put it in your notes. Alright, so let's get started. Firstly, when I asked you if water is a solid or liquid or a gas, the truth is it could be any of those things. And the same is true for iron and neon. All three of these could all be solid, liquid, or gas. I would point out that manipulating them between solid, liquid, and gas, however, would depend on temperature and pressure. So we can use a combination of temperature and pressure to change it between solid, liquid, and gas. So basically, whether these substances are solid, liquid, or gas depends on the substance's surroundings and the conditions of those surroundings. So heat and pressure are applied to the substance. And it is a little bit confusing because sometimes we say that group 18 elements are all gases, but why do you think we call them gases if we know that they can be in any state? Pause the video and think about that. So that's because they are gas at standard temperature. So when we say that things are gases, what we're not saying is that it's in reference to a standard temperature. So by definition, what is standard temperature and pressure? You can find these on, I believe, table A of your reference table, and it just says what they are, and there's a couple of different units for each. So what you'll find on table A is that standard temperatures could be 0 Celsius or 273 Kelvin, and standard pressure is 1 to 1.3 kilopascals, or 1 atmosphere. We'll use all of these this year, and it just sort of depends on the situation which one we'll use. So I think I got a little bit ahead of myself, and we just answered this question already, so that's all set. Let's review the properties of metals and nonmetals, and this time we'll keep in mind that these are properties at STP. So the difference between a metal and a nonmetal is namely metallic character. So the more metallic something is, the more likely it is to be a metal, and the less metallic it is, the more likely it is to be a nonmetal. We'll find nonmetals on the periodic table on the top right, and some of their properties I will write in right now. So they're brittle if solid, they have low melting points and low boiling points. They could be solid, liquid, or gas, and they're not conductive in their typical states. Alright, then we have where are the metals located on the periodic table. Those would be on the bottom left. And I'll put in some of their properties now. So I just said malleable and ductile. Malleable means that you can be pounded into a sheet, and ductile means you can be pulled into a wire. So here's a picture of ductile, is wires being pulled. And then malleable, I have a picture of foil. So foil is a great demonstration of malleability, and making something into a wire is a great description of ductility. So also I just said that typically metals are solid. The one exception that I think is important for you to remember is mercury. So this guy, Hg, mercury, that will be an exception because it's liquid at room temperature. And then in general, just remember that they have high melting points and high boiling points. Now we'll find the metalloids bordering the staircase, and I'll tell you why they're called metalloids, and that's because metalloid means that it's half metal and half nonmetal. When you have this suffix OID on something, it means sort of like semi or almost. So they're almost metals. So they'll have properties of metals, but they'll also have properties of nonmetals. All right, transition metals. We can find those roughly between groups 3 and 12. And that basically is just that little dip in the table between the two taller portions. And transition metals are just, I guess what you should know about them is that they are metals, but they have unpredictable charges. All right, here's a good one. This will come up a lot. How is it possible to recognize the ions of transition metals? I would say put a star here because this one does come up a lot. And I put a little picture example. So these solutions all contain the ions of transition metals, meaning that we took one of these guys that have the unpredictable charge, and then we gave them a charge. And then what happens is that if a transition metal ion is dissolved in water, it turns into like this really beautiful color, like maybe red or orange or yellow or green or blue or purple. Now that'll completely depend on what element's ions are dissolved. For instance, rubidium will make a very red ion and lead makes purple. Depending on the kind of copper, you could get green or blue. So that's how you recognize transition metal ions, is by rainbow colors. Now, an allotrope is two different forms of an element that have different molecular structures, and therefore they'll have different properties. So I just wrote that in here. Same element, different molecular structures with different properties. And some examples of allotropes include diamond versus graphite. And both of those allotropes are made of one element, which is carbon. So that's why I would say they're the same element. But they have different molecular structures, and you can see that reflected here in their diagrams. In diamond, there's a lot of cross-linking between molecules. So instead of just having a flat sheet, there's also interlinks between those sheets. Whereas in graphite, what you really just have is just these little sheets of graphite that are not linked in between. But they're both made of carbon. They're just, they have different molecular structures, and therefore they will also have different properties. So same element, different molecular structure, different properties. So in addition to the examples of graphite and diamond, you also have the example of ozone versus oxygen. They're both made completely of one element, which is oxygen, so they're the same element. But they have different molecular structures. You can see them here. Ozone has 3 oxygen atoms bonded sort of in a bent structure, and oxygen has 2 atoms in a straight line. So they are the same element, and they have different molecular structures, and therefore they have different properties. This guy is important for our breathing, and this guy is important for blocking UV radiation. So very, very different. All right, so states at STP. There are, basically, here's what I want you to remember, which is that at STP, every single element is a solid. So just think about it like that. Just think that every element is a solid at STP. And then, if you can remember A through H in terms of exceptions, then you'll know the state of every element at STP. So just say that all elements are solids. I'll outline solid. So all elements are solid except for mercury is a metal that is liquid at STP. Bromine is a nonmetal that is also liquid at STP. Hydrogen is a nonmetal that is gas at STP. Oxygen is a nonmetal that is gas at STP. Nitrogen is a nonmetal that is gas at STP. Fluorine is a nonmetal that is gas at STP. Chlorine is a nonmetal that is gas at STP. So for all those ones that were just very repetitive, all the nonmetals that are gas at STP, I have something I want to teach you in class called the Heavenly Seven, of which these are 5 of the Heavenly Seven. And actually, another one of the Heavenly Seven is bromine, and the other one is iodine, but it's not listed here. I need to be able to gesture at a periodic table to give you a good understanding of the Heavenly Seven, so make sure you ask me about this in class. And then lastly, I think this one's obvious, which is that noble gases are also nonmetals, but it's right there in their name, noble gases are gas at STP. So that brings us to the end of the lesson. I just need to make sure that you copy this pair up on the same piece of paper that you copied the do now, and then all of that should go under classwork in your binder, and it should be separate from your notes. Give everything a great title and have the correct date. All right, thank you.